like in today's world, most of us, we are so good with technology, and technology is becoming incredible. We feel so good with that, but after coming here, I just did understand that this all professors and PhD students in the whole university, what's going on, and every day it made me so emotional. Somebody is still working on the things like whole life, but not for earning money. Thank you so much. And my project, I'm not going to talk too much about that. I will be so fast, I hope. I will try. And most of it she did talk about. And as you know, it's very important to choose a special, effective title to make somebody to worry about your project, like curiosity about your project. Safeguarding water with nanoporous innovation. So there are many other ways, but ours is nanoporous innovation, and I will just try to make us, all of us, to understand how and why. The background of the project, why dye as a contamination. So as we know, pollutants are variable, but we did focus on dye. Why on dye? Because dye has poisonous effect, and she did already talked about the effect of dye in water to our life, and effect of dye in the aquatic organisms, effect of dye in industry. So I will not repeat it. I just want you to focus on some specific scientific data. They are very important because, like, please look at there, it says just industry. Like, it says just the textile industry alone is responsible for discharging approximately 280,000 tons of dyes annually into the water bodies. So let's guess how much it will affect all aquatic organisms at the beginning by blocking sunlight and oxygen, but later how it will affect our life, because most of the, as you know, 90% of the oxygen is coming from the cyanobacteria, and this process will affect, like, from the beginning, producers and us, and even the environment. So what is the problem? To try to understand it correctly, synthetic dyes in wastewater are hazardous and difficult to remove with existing methods. Difficult to remove because it takes too much time, this is important, and cost too much, it is also important. And the way you try to do, it needs too much effort to do it. So we need today cost-effective and easily productible materials are needed for efficient removing dye. And what's our hypothesis about that? The synthesizing a porous organic material, organic polymer from organic waste, even organic waste, it's very important. Why? Because not from just chemicals, from even organic waste you can produce our product. So let's guess how usable it is because of the recycling process. There are many other purification methods. I don't want to take your time, so I'm not going to focus on all each. But let's take a look about adsorption, and even my partner did explain what is the difference between absorption and absorption. And here there are two things which is important. Highly effective for organic pollutants like dyes, which is our focus contamination, and common absorbents include activated carbon, clays, and novel materials like HCPANI. And uniqueness of our product. Uniqueness of our project. Yeah, we did choose the absorption methodology, but also it is important why we did choose to produce this product. Because of the high efficiency, versatility, and cost effectiveness. I'm not going to go deep, but if you want to learn more, we can of course share. And we did try to choose nanoporous organic polymers to focus on and how to absorb the dye from the surface. This is important because we will later talk about our product. It is recyclable, so you can recycle it, you can reuse again and again. There are 3 different sizes, as you know, for the nanoporous material: microporous, mesoporous, and macroporous. Our product is POP. POP has like one not nanometer, micrometer. So like 10 power minus 9 is nanometer. Ours is like the particle size is 10 power minus 6. So that means you can understand that if even the particle is that much small, how much pores are included. And our research project was going on synthesis, characterization, and post-reaction workup. Of course, you will have in all different research projects. And our goals, we did talk about that. And application. So we did try with many different variables, 3 different times. We did have chance to try some variables on it, but we did not have chance to try all in 6 weeks. 2 reactants we have, which is main in this reaction to produce our product, POP. 2,4-diamino, 6-phenyl 1,3,5-triazine, and cyanuric chloride. Why these materials? My partner did explain. Thank you so much. And again, but I want you to focus that. Yes, I say cost efficiency. So what does it mean? I can explain you like that. $135 cost for 1 gallon, cleaning of 1 gallon of water. So $25 cost for 1 liter of water, but in the way we did in the laboratory. Let's guess if a factory is working about. So if a factory is working on it with the big equipment, it will cost less than that. So I'm not going to talk about preparation too much, but I just want you to focus the way we did. We did try to take the temperature constant. We did try to take the volume constant. So we did use the condenser. We did use oil bath. And for neutralization also, we did use another reactant, which is triethylamine. And the amount, we just did start with millimole. Do not waste too much reactants. And because you need first understand what is the best way to produce your product, because you will try to look at the characterization and qualification. So we did use 1 millimole from each, about amount millimole. And we did try the reaction 3 times to understand the time, which is the best time to wait for the best qualification. And my partner did talk about the process, so I'm not going to repeat it. I don't want to take your time. Yield calculation, we did yield calculation to understand the quality of the product. So we did 2 ways. One of them, we tried to check under UV, FTIR, the product. The other one, we did try to check with the yield calculation, the amount of product, the best amount of product. So at the end of the yield calculation, you can see in here 3 different product amounts. First one is after 8 hours later, 16 hours later, and 24 hours later. So you can see the yields in here. As you see, the 24 hours is the best option for the time, for the more amount of product, because the yield is 54%. So it is very important. So we did guess, yes, if you wait to have more product, it is better. But what about the qualification? Like, let's check under FTIR, like, how is it? And we did check, and finally, like, we decided that best product yield and quality achieved with 24 hours. My partner did talk about a graph, so I'm not going to repeat it. We did absorption experiments. So I'm not going to talk about all, but like 100 milligrams of crystal violet dye. Why crystal violet dye? Because we were trying to like use the crystal violet dye, also known as Jantan violet, is commonly used in the dye absorption studies, so we did use crystal violet dye, and because of its intense color also. We did prepare the different concentrations, and we did the UV analyze. She did talk too much about that. So, and also, after deciding 24-hour product is the best, we did continue with the 24 hours product. We did produce more amount of product, and with more amount of product, we did check some other different conditions for the application process. Because you will try to understand like which one is better for the application process. I mean, like how much it clean the dye from the water, and what is the best option to do during this process. First, we did check effect of initial dye concentration, and second, we did check effect of absorption dosage, and last, we did check effect of time, which is better, like again here for the application process. Initial dye concentration on absorption process, you can see in the graph, like we did prepare 6 different types of concentration, and we did check them. At the end, we did decide that like there is a problem in here, just the 30, like I think it was like a challenge in the lab. Normally it doesn't, like it shouldn't be like that, but it was. We did check again and again, but with the same product. I don't know what happened there, so I cannot explain it really. But what about the result for the dye concentration? As you see, the 50 ppm, like the higher peak. So that's mean like if you use more, it will be harder. So you need more product, but we did use same amount of product for each. And absorption results, we did change the amount of products. So we did use, like here, this is the stock solution, no product in it, but here we have 20 mg and 30 mg and 40 mg of product in same amount of solution of dye, crystal violet dye, and with the same concentration. But look at here, please. The 41 is so clean, and it's a pair how much it did work. And I think, like as a result, even the doctor which is working with us, she told us like the 40 mg will be enough to clean the 90%, maybe 99% of crystal violet dye from 10 ml, 5 ppm solution concentration. So it was a good result with 40. We did try with 50, actually nothing did change. So that's mean like you almost clean with 40, you don't need more. For the kinetic study, again we have surprise with 1.5 hour, we don't know what's going on, like we did try 2 times, but same results we did have, and even the doctor did try it, and again 1.5 hour gave the same result, not effective in the graph. So we just decided that for the application, you should wait over 1 hour, maybe 2 hours is enough. We should try to do it again, like between 1.5 and 2 hours, because we don't want to wait more. Yeah, conclusion. So as a conclusion, the synthesis of nanoporous organic polymer was successfully achieved using the conventional heating method, characterized by moderate temperature, reasonable reaction times, and cost-effective procedures. The sample absorbent was characterized using FTIR and SEM techniques. Thank you so much. They did give us chance to see this equipment and to do our research with that. And finally, we decide that for 5 ppm of 10 ml solution, 24 hours product will need 2 hours of application, and it will clean 99% of dye from the water. And this is our product before and after. So you can see how much dye it absorbed. But finally, the good news is you can also recycle it. Yeah, it is very easy process. Just separate and clean with sodium hydroxide and rinse, dry, and use it again. I'm not sure how many more times you can do that. It's another research project, and, but we are happy because we did finalize our project. This is the last picture, so we are so happy. As you see, as a scientist, we did our work. Thank you so much.
Very good.